I guess most of you know that computer stores information in zeros and ones. If you open your calculator and write 4 plus 2, the computer will translate this information in the way it understands, then does operations and returns the result. The result that can be understood by computer, human, or even a baby that just counts apples. Math behind all these 3 layers is the same, so we can say computers understand numbers. But what about words? If you want to translate this beautiful creature into computer language, you will use ASCII table. We transform words letter by letter. The problem here, these numbers doesn't have any sense. So instead of ASCII table, we will use technology called word2vec, the technology that will extract meaningful numbers, the numbers that will represent real world object. This technology will take our word and transform it into vector. That's why it's called word2vec. But why we use vectors? And what is this? So, this is a number, this is a vector, this is also a vector. Now you know vectors. Yes, the vector is just a set of numbers. That's a great structure for computer world, because we can represent objects in vectors. Like here, height and weight of a human can be represented as vector. We can do a lot of fun stuff with vectors. For example, visualizing. We can even visualize objects without numbers. It's still easy to understand that giraffe is far from a human. The next great thing is we can do some math with vectors. For example, adding and subtracting. Here vectors represents a bag of fruits. If we have 4 apples and 2 oranges and then buy 2 more apples and 1 more orange, we will have 6 apples and 3 oranges. More about vectors you can find on the 3 Blue 1 Brown channel, but now let's focus on visualizing and math operations. Because word2vec transform words into vectors, so we can visualize them and do some math operations. And this is really cool, let me show you. So we have a plot and we transform word cat into vector. We plot this vector and then transform the next word, the word earth, and then plot it. And because these words don't have the same meaning, they are really far from each other. If we add more words like dog or sun, they will group by sense. The earth will be close to sun and the dog will be close to cat. How is it even possible to transform words into some meaningful numbers? We're just starting. The next thing is math operations. Let's look at them. Let's do Galaxy minus Samsung plus Apple. Transform all these words into vectors. Okay, subtract, add, and have a vector that represents iPhone. What? Math with words? What? How? Okay, let me explain. Let's dig into this black magic. Firstly, let me show you some word. Do you know this word? No? Let me add some context. You still don't know this word, but now you have some information. Two-headed. This is some mythological creature. Okay. So, more context. Okay. Two-headed evil creature with legs and belly. What's interesting here, you didn't read any definition. You just extract the information about the word from its context. John Robert Firth said, "You shall know a word by the company it keeps." Here we can see, if 2 words, orthos and hydra, have the same context, they also have the pretty close meaning. The same for dog. Dog can laying belly up, and the orthos can. And so orthos, that's a dog from Greek mythology. And we can do this in a reverse. What word is missed? Okay, let me say water. Why not? But you can say cola or Fanta. All these words have the same context. That's why it's so close to each other by meaning. Let's a little bit change the context. Now we have sugar. Okay, I will say coffee, water, and tea will be the right words for this context. Now let's visualize this. Cola and Sprite will be on one side because they have the ice context. The tea and coffee will be on the other side. And the water somewhere in the middle because we can meet it in both contexts. Let's describe it in more math way. For that, we will use probabilities. Look at this sentence. The probability that it will rain in the evening if it's cloudy in the morning is high. And rewrite this in math way. Just the same stuff. Rain in the evening is an event, and cloudy in the morning is a context or condition. The result is a number between 0 and 1. Let's use this technique for our words. Here's one more sentence. I think you can read it yourself. So that's the math way to represent that sentence. So we have word and have context, W and C. Let's add more examples. Water and drink, high probability. Sprite and drink, high. Guitar and drink, low probability. These are our examples. The real task looks like this. The probability to meet the right word with the right context should be high, and with wrong context should be low. But actually it's called a fake task. Are you confused? Okay, why it's called fake task? To answer this question, we need to go deeper. Behold, the neural nets. More about neural nets again you can find on PreBlue1 channel, but I will stay on a high level. So that's the neural net. You can think about each circle as a number. Firstly, let's take a look on the first and the last layer. They called input and output. Remember our sentences? Let's extract all words from these three and also this three. So we have 8 words. And these words will be the input and output for our neural net. Now, remember our probability? Okay, so let me add some real words like cola and drink, and the neural net works just like this probability. It takes a context and returns the probability of a word. You can pause and see that these things are just the same. But again, why fake task? So here it is. The fake task means we're not interested in the results. We are interested in the process, in the vector inside neural net. Do you see the blue lines between neurons? Think of them as encoding and decoding. The neural net tries to extract the information from the word to solve fake task. So here is our vector for word drink, just the middle layer. And now you can do this for all 8 words. And finally, see the pattern that we already saw. The cola and Fanta on one side and the tea and coffee on the other. But we have much more words than 8. So here is 10,000 words that were produced by word2vec. Just see how beautiful it is. All these dots are actually a piece of math, so we can do anything with them. Visualizing, like right now, or math stuff, like I showed before. But they are not only numbers, they are meanings. And I know I skipped a lot in this video. I didn't say anything about the neural net learning or about creating dataset, because this video is not about computers. It's about idea that every one of you can use. I guess the best way for people to learn new words or even a new language is the way to learn things through the context, by reading books, watching movies and stuff like that. And if the computer can do this, you also can. I want to thank Grant Sanderson for creating this beautiful competition, and also thank you all for watching. You can like and subscribe because this is not the last video about word2vec. So